All right. Good morning, everybody, or I guess good afternoon to some of you also. Excited to get to think this morning or this afternoon with you a little bit about counting. So, we know that counting matters, right? Counting's long time been something that we work on a lot in early childhood. But what I hope to do today is to get into some of the complexities of counting and to help us think about why it's not just important for young kids, but the ways that it provides a foundation for some later kinds of mathematics. And I also sort of want to think about um, kids' intuition and how kids are naturally brilliant in what they figure out how to do around counting. And so we have some ideas about what to look for and what to listen for that is going to help us to think about some of those things. So as you are entering in, I see people are making some nice comments. Feel free to introduce yourself if you like, and I'll just say a tiny bit about myself. So, my name is Nick. I'm an assistant professor here at San Diego State University. I also direct our local math project, the San Diego Math Project here at SDSU, which is one of the sites of the California Math Project that are across the state. So a lot of the resources that I'm going to share with you today come from work that we've done and that we're continuing to do across the state in the California Math Project. All right. So let's get started here. Uh, as we as we get into things, I just want to acknowledge all the wonderful support for this work that we've received from the Isaac Simons Foundation, who's funded the Dream Teacher Education site, which I'll share some of these resources with you, and also the National Science Foundation, who's continuing to support some of my work in trying to understand what's happening in early childhood classrooms. And much of what I'm going to share today is the product of collaborations with folks at UCLA, folks at Stanford. So I'm excited to get to share our collective ideas with you all. So I want to start today by talking a little bit about counting collections. So my guess is that counting collections is familiar to some of the people here today. So if it's familiar to you, fantastic. You can add on to things, and if this is new, hopefully you'll see something that you want to take with you. But this is an activity that we get to use over and over and over, and the activity sort of grows along with teachers and students. So we'll look a little bit at the activity and an example of that, and then I want to get into some of the research on learning to count to help us think about how we recognize how brilliant young people are and how we can raise up and build from what they know and what they can do. So counting collections is sort of simple in some ways. Like often we do, we gather collections of stuff. So you can see in the photos some of the different kinds of things we invite children to count. And the directions to the task are simple. You just ask the child to figure out any way they want how many are in your collection, how many of these beads, how many of these little toy sea creatures, how many of these popsicle sticks. And sometimes kids do this by counting by themselves. Sometimes we invite them to count with a partner. And then after they're done counting, we invite them to represent on paper something related to how they counted, show their collection on paper. And part of what makes this task useful is that it's sort of pretty simple to get started, but that there's lots of different directions it can go. And we can do this same sort of task over and over and over in our classrooms across grade levels. And so when kids get to a new classroom or a new grade level, they they can be familiar with this activity. They don't have to figure it all out. They know how to participate. So it's useful in helping us think about coherence across classrooms. So you'll sort of see here in the photo some young people counting some things and trying to represent their collections. But I think what I want to do is I want to share an example with you that comes out of a preschool classroom. But before we watch the example, I want to give you a couple of look fors. So I want you to think about as you're watching, like what kinds of learning are available here. What kinds of mathematical learning opportunities are there, and also like children learn more than math in classrooms. They learn about who they are, who one another are, sort of what it means to do mathematics, and they have a chance to build ideas together. So I want you also to like notice like what kinds of social and collaborative learning opportunities there might be here. All right. So the video that I'm going to share comes from some of our resources on the Dream TE website, and this one is how Ms. Gaxiola is going to engage a small group in counting.
We're going to do our counting collections. Are you guys ready to go to counting collections? Yes? Okay, go ahead and walk to your table, get your chair. All right, here are your keys. Go ahead and count your collection.
It's 11.
How do you know you have 11?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
You do have 11 keys. Can you count for me, Vivian?
Casilla has swimming. It has 7. Casilla, it has 7.
Okay, can we count them one more time, please? You have 7 keys?
Yeah. 2, 3, 4, 5, 6, 7, 8, 9.
How many do you have?
Yeah.
9.
13. Wow.
Can you organize them for me in a different way? Okay, try doing that.
I'm done.
You're done? Oh, I see that you made groups. How did you make groups?
7.
How did you sort yours? You put them by the same size or the same color?
Same color.
Okay, so which of your groups has more? You're done? Can you write your numeral on there? Like what? The number. How many you had? How many did you have again?
7.
7. Penelope, I see that you made a straight line. You organized them differently. Can you count for me? Go ahead and count. Can I ask you for a favor? When you count, can you move them? So either you can move them up or move them over so that we can see how many you have.
7. Yeah. Teacher just has 7. You forget the one more.
Okay, are you ready to represent? Okay, go ahead and draw for me how many you have. Okay, can you make groups with Penelope, but can you talk to her so that she knows what she's doing? Okay, go ahead and talk to her. You made 2 groups. How many are in each of your groups?
You're gonna do this, okay? The purple one, put it by itself, and then the 2 blue
Oh, you
ones,
counted
put
them
it-
all together. How many are in this group?
No, don't
Just
put
this
it
group.
part of this.
4. How do you know there's 4? That was a quick
No,
response.
put that one.
And how many are in this group?
No, put that one. You're not you have a lot of keys. And put these like 4, 5.
5. So which group has more?
The black.
That side has more, right? Okay, can you represent your whole collection? Oh, you want me?
Teacher, look.
Yes.
Teacher, look.
What did you guys do? Ask her how many are in each group.
Teacher, look. Penelope, how many are in each group? Look. How many are in each?
Oh, you traced each one, huh? So how many do you have on your paper?
This one? 2. 2.
All right. So lots and lots going on there. But if you can take a moment, and if there was something that stood out to you, you can drop a note into the chat, or if you noticed particular things related to the kinds of learning opportunities. I'm interested in what you all are seeing there, both in terms of the mathematics that young children get to work on, and also in terms of some of the social and collaborative elements of participating together in collections. So I'll highlight some of the ideas that are coming in. Yeah, it's a real classroom, right? Like there are many different things going on. And see the teacher really moving back and forth between lots of different children who are participating in lots and lots of different kinds of ways. We have yeah, there are some like different kinds of items that children are counting. So depending on what the items are, right, children oftentimes approach the collection differently. We saw some kids uh, starting to sort and organize things in different kinds of ways. There's always a lot of "Hey teacher," right? Um, and so Carolina asked, like, how do you introduce this? So the directions are sort of really simple. You just ask kids, "Here's a collection. Can you try to figure out how many there are?" We let kids kind of decide how they want to approach it, because one of the things that we've learned, which I'll go into in a moment, is that actually there's lots of different ways that kids will try to figure out how many are in their collection, and there's lots of really nice mathematics in the details of the different kinds of ways that they do things. Okay, so let's keep going here a little bit, you all. Thanks for those comments. So, by the way, before we leave, this comes from our Dream website. This particular video is actually available here, so I will share this with Naomi, and she can put it into the chat for you all in case you want to come back to this or share it with a colleague. So
And today,
Whoops. So, what I want to spend a little bit of time next on is digging into some of the details of how young children learn how to count, and some of the things that help us to notice what it is that they can do, and how sort of powerful their intuitive mathematical brilliance is for a lot of our counting. So we're going to start off with a young person here, and her name is Nicole, and she's going to count a collection of these little plastic frogs. And in all of these examples that I'm going to share, we're going to see how learning to count is actually a little bit bumpy, that kids don't always get it right. And so what I want us to focus in on is not sort of what they're still working on, but what it is that they understand and can do related to counting, because we know that's actually how students learn. It's from building from what's productive in their ideas. All right, so let's see what Nicole does, and she counts really quietly, so you gotta listen hard.
yes, do you think you can count all these frogs for me?
One, two, three, 5, 6, 7, 8, 9, 11, 12, 13,
Wow. How many frogs do you have?
14.
That's a lot of frogs.
Okay. What did you notice? What's Nicole understand about counting? What's she able to do? What was her approach to trying to count those frogs? Go ahead and drop an observation in the chat if you have one. So one thing, right, is she lines the frogs up, and uh, what some people are noticing here is it's not just lining up that is her organizing, but she kind of orients the frogs, right? She turns them around in a particular way, and that's actually really important for Nicole in keeping track of which ones she's counted, as she's saying the number names as she puts each frog in its proper position. Um, it's helping with that idea of one-on-one correspondence, right? That you say only one number word for each object. And yes, she skips 10, right? But one thing that some of you noticed here is there were 12 frogs, and she used exactly 12 unique number names. So she actually demonstrates in this example, she demonstrates accurate one-to-one correspondence, even though she doesn't use the standard number sequence. And it turns out that this happens a lot if we start to look for it, that you don't actually have to know all the names of the numbers before you can demonstrate that you sort of have this idea that I'm going to match each object with the number word. Other things that people noticed here? Yeah, so at the end, she asked this question of how many, and Nicole answers that there's her sort of idea of 13, how she says it, right? But the last number that she says tells her this total for the collection. All right, let's do another one. Let's do another one here. So this is Aubrey. Aubrey's got a little collection of 9 bears here.
Can you count them for me, please?
1, 2, 3, 4, 5, 6, 7, 8, 9.
How many do you have?
1, 2, 3, 4, 5, 6, 7, 8.
How many are there?
1, 2, 3, 4, 5, 6, 7, 8.
You have 9, right? So how many do you have?
1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay, you've seen it before and you will see it again. So talk about Aubrey here. What did you notice about Aubrey's counting? What's she doing that's brilliant, right? She knows some things about counting. What are some of people's ideas about what they saw Aubrey do here. Yeah, so right, part of what she's working on here is that counting has an outcome. Like counting is a process, but it's a process that tells you something. It tells you an amount. It tells you a quantity. So she's able to do a lot of nice counting work here, but when asked, so okay, so how many bears is that? She just recounts, right? Of people seeing kids do this, right? Or sometimes they'll count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and we ask how many, and they say 3, right? Why? Because they're 3. So sometimes kids can do some really nice counting, and they're still working on this idea that counting actually tells us some things. Um, but like there are some really nice instances of counting understanding here. On most of her counts, she's really working on this idea that I'm going to touch this bear. It's going to help me keep track of which ones I've counted, where I am in the sequence. I'm going to match things up. She knows the number sequence people are pointing out, right? We get to hear her use this same number sequence 1 through 9 on more than one time. So some really nice understandings here that you can build on. Okay, let's see. Let's do one more. So this is Scarlet. So Scarlet's gonna count this collection of nine of these tops. So these are like you go to Target and you get the little applesauce. They're like little propeller caps. Oftentimes we just ask our children and families to bring in things that you would normally just throw away, right? And then we get some nice collections. But these are those little tops. So Scarlett's going to count these more than once, and we'll think a little bit about what it is that she understands here, and some of the ways that the teacher might build on what she's able to do.
Do you think you can count these for me? Yeah? Yeah? There you go. You can pour them out, you can move them around, you can do whatever you want. Did you count them?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
How many do you have?
10.
Awesome. Could you count them one more time for me? Nice and loud so I can hear
1,
you.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
How many do you have?
11.
Okay. So first round we got 10, and second round we got 11. I'm curious if you noticed how her approach to counting, it actually shifted from her first count to her second count. So right, so on her first count, she is trying to stand them up, right? Those little propellers, they can kind of stand up. That's one of the ways that kids come up with to keep track of which ones they're counting. It helps them with their correspondence. But then one of them fell over, right? And so her system got a little bit mixed up there. The second time, they're already all arranged, and she just tries to point and count, and she's again off, but she's actually off by even more than the first count. And this is something that we actually saw happen often in some of the research that we did. Oftentimes, for young kids, we tell them to line them up, or we even line them up for them, because the idea is, ooh, I'm gonna make this easier for you. But actually, it turns out that sometimes lining them up doesn't help kids. It makes it even a little bit harder. So one of the things that we've seen teachers do that seems to be helpful is they let kids decide on their own. Like, how do you want to organize them? How do you want to keep track? How do you want to go about counting these? Because kids come up with lots of different ways of keeping track. So we've seen Scarlett count twice. She's got a nice number sequence, as people have pointed out, even though she's arriving at different amounts because her one-on-one correspondence is something that she's working on here. She answers this sort of how many question at the end. So she's sort of putting this idea on the table that counting tells me how many. So let's see what the teacher does here to think about how to help her with this idea of one-on-one correspondence.
Awesome. Hey, Scarlett, can you count them one more time for me? This time, could you count them as you're putting them away back into the bag one by one?
2, 3, 4, 5, 6, 7, 8, 9.
How many were there?
9.
Awesome.
So, right, this invitation to count them again, but to move them sort of helps her slow down a little bit. And then she even has that moment, right, when there's 2 in her hand, and as a teacher, right, we're often like, oh no, right, we want to jump in and help them there, but she's able to handle that, to see that I gotta only drop in one at a time as I'm sort of counting the numbers here. Okay. All right. I want to try one more example with you all before we talk a little bit about some of our research findings and a little bit about representation. So this last example comes out of one of the resources that my colleagues and I have published related to this work. So I'll put the link to this blog in the chat. But this comes out of the Young Children's Mathematics book, and we're gonna watch Hazel, who is about 3.5 here, count a collection. But one of the things that we became really interested in is, what do kids do when you give them a collection that has like way too many, right? Like way more than you would expect a young person to count. Like, what can we learn about their emerging understandings of counting? And so I'm going to invite Hazel here to count a collection of 30 pennies. So she's 3.5. She doesn't know really how to count to 30, but I want you to notice some of the things that she's doing as she's trying to problem solve around this. You've got this giant collection. How do you negotiate figuring out what to do with 30 pennies when you're still sort of working on a lot of these pieces of counting? Can you help me count these pennies?
Yeah.
How many are there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 16, 17, 18, 19, 11, 12, 14, 16, 17, 18, 19, 11, 12, 14, 16, 17, 18, 19, 11, 12, 12.
How many are there?
12.
All right. What'd you all notice going on there? So she doesn't know how to count to 30, but what does she know about counting, Wall? Go ahead and drop your ideas in the chat if you notice something interesting or something that she did that you think was smart. Question that came up for you. Right. So one thing is you see a lot of one-to-one correspondence. There actually, like at the very beginning, if you have watched this as many times as I have, she actually double counts like the third and the fourth one. They weren't quite moved over enough. Like her system for counting, right, was to slide them over. That's sort of how she figured out which ones I've counted and which ones still need to be counted. But the third and the fourth one, like she wanted to move them a little bit farther, and so they actually got counted again. They were 5 and 6. So early on, we see her still working a little bit on one-to-one correspondence, but it actually gets better the deeper that she goes into the collection. And it turns out that this is common a lot, that giving kids a whole bunch of things to count oftentimes helps them get better at one-to-one correspondence. Other things that people notice. Let's see. Oh yeah, here we go. Right. She restarts with 11, right? So you run out of numbers and you go back, but she doesn't go back to the beginning. She goes back to 11. So one of the ways we can think about this is she does know something about counting into larger numbers, which is like when you get into larger numbers, you reuse part of the sequence you've already used. She doesn't quite have that idea, right? But like right when we get to the 20s, we hear 21, 22, 23, we hear the 1, 2, 3 in the 20s. But there's sort of this pattern to the number sequence. So it may be that she's sort of trying on this idea a little bit with the teen numbers. Let's see. Yeah, she counted to 12 and then she jumped to 14, right? She skipped 13, and actually she's consistent with the numbers that she uses and the numbers that she skips. She skips 13 and 15 each time. But she has, right, 16, 17, 18, 19. She has those later teen numbers actually sooner than some of the earlier teen numbers. And this is another thing that it turns out is common, that oftentimes once kids can get to 16, they can get to 19 because the number, like the structure of the number sequence is a little more transparent there. You can hear the 6 in 16, you can hear the 8 in 18, but you can't hear the 3 in 13, right? Why did we name it 13? We should have called it 3-teen or 10-3, right? So it turns out 13 and 15 are the most common numbers that get skipped in the teen sequence. And one of the things that we've found is oftentimes kids can do a lot more even while they're still working on the teens. So I'll share a little bit of that research with you in a moment. And then a lot of you are sort of focusing in on like her perseverance, right? Like she has a lot of confidence here. She doesn't give up. So, right, part of this is like, do we allow kids to go with their ideas? We know like what kids are oftentimes going to take some more time to work with, but like one of our goals is often not necessarily for them to get it right there and right now, but to have them want to count with us again next time. So we can build this sort of perseverance and confidence if we encourage kids to trust their ideas. All right. So I want to use sort of our last 10 minutes to talk just really briefly about a little bit of our research findings and to also talk a little bit about representation. So in terms of really thinking about the complexities of counting and helping us to recognize children's brilliance, it can be helpful to think about some of these principled ideas in counting, right? So part of learning to count is learning the sequence of number words, but also part of this is that as you count beyond 10 and especially like into the 20s and the 30s, you get a chance to start making sense of the patterns that are there because of the base 10 system. And so counting, very little of counting is actually memorizing. A lot of it is about trying to sort of make sense of the patterns in the numbers. We've talked a lot about one-to-one correspondence, and then we also sort of see this idea of the cardinal principle or cardinality, that understanding that one of the ways that we can think about numbers are as amounts, and that counting has this outcome. But I also want us to think a little bit about how these ideas get extended throughout mathematics. So the one-to-one principle is sort of a specific case of this larger idea of correspondences in mathematics. And so that happens as we go on and on in mathematics. So if you think about when kids try to compare things, oftentimes they make correspondences between two sets to try to figure out how many more a set is. Later in multiplication and division, kids have correspondences between groups and the number of groups, or the number of items in a group. So you have one box of crayons that has 24 and two boxes of crayons has 48. And then even into proportional reasoning in middle school and linear functions, this idea of correspondences is a huge through line in mathematics. So as we're helping young kids develop ideas of correspondence, it's not just about counting. It's about where this idea goes on and on mathematically. All right, so let's just share a tiny bit of some of our recent research. So I mentioned this pennies task, where we were interested in what happened when we gave kids collections that were too big to count, but we tried to pay attention to what they did as they were trying to negotiate this larger collection. And one of the things that we saw was that the use of these principles doesn't sort of follow a sequence. So it's not true that kids need to know the number sequence before they can use correspondences, or that they need to have correspondences correct before they can tell you how many are in the collection in a way that's consistent with the last number that they said. And so so that led us to see that these don't really develop in isolation. They need to be developed in relation to one another, and counting objects helps this. And so we really are encouraging people to think about development of counting as more of a constellation of different ideas coming together in different ways, rather than something that's sequential. So that article came out a few years ago, and then in a really recent article that just came out, led by my colleague Brandon McMillan, who's at BYU, we looked at kids over 2 years, and one of the things that we saw was we tried to look at what they did after they made a mistake in the number sequence, and we saw some of what we saw in that Hazel example, that before kids used the correct sequence, they actually demonstrated a lot of understanding of some of the structures of the number sequence. So that's within the teen numbers and even like into the 20s and 30s. Some kids are still working on the teens when they understand the 20s and the 30s. And so I think one of the things that means for us is that we can give kids larger collections, and that helps them make sense of the teens to get into the 20s and the 30s, where the structure becomes a little bit more regular. Okay. So we have just a few minutes left here. So I want to come back to this idea of representing their counting. So part of counting collections is to try to figure out how many are in your collection, but also teachers invite children then to, can you show how you counted on your paper? And again, kids come up with lots of different ways to do this. We'll sometimes see kids trace their objects, or they'll make tally marks. They'll do lots of different kinds of things. We see here, right? Kids can start to attach numerals to groups of things eventually. But we also see, right, that sometimes children are still working on this idea that I have to have the same amount on my paper as I actually there were in my collection. So you see, Maya here has a lot of gems, and so she drew a lot of gems on her paper. So this is another way that kids get to work on these ideas of one-to-one correspondence and cardinal understanding of number through trying to represent their collection on paper. We'll watch just a short clip here of a couple kids working on this idea of representing.
7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19, 20.
How many do you have?
20!
Okay, so how are you going to show that on your paper?
¿Cómo vas a saber cuántos tienes de estos?
2, 3, 4, 5.
Es que yo creo que hiciste, you did the numbers too close.
6, 7,
Is there more? Do you have no? You don't have any more? How many do you have there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
How many do you have?
12.
Very nice.
¡Me ganaste! Oye. ¿Qué me gana? Solo hice los números.
All right, so how many do you have, Daphne?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16.
How many?
16.
Very nice. Do you know how to write the number 16, Daphne? Yes? Okay, let's see. How do you write 16?
And what?
You tell me. How do you write 16? Okay, so how many do you have?
16.
Excellent.
Right? It makes sense, right? Of course. You hear the 6 first. Why wouldn't you write the
8, 9, 10, 11, 13, 14, 15, 16, 17, 18, 19.
Sorry, folks. All right. So again, this is something that takes time to develop, but we can ask kids questions about their collection. We can ask them questions about their representations. And we see that over time, right, we can develop lots and lots of mathematics this way. Kids will start to group things, use tally marks, tens, and all kinds of really powerful things come as kids advance through the grade levels. So I believe this is time for us to go, but you can see here some of the resources that we've drawn on that are all publicly available. Lots of these things are available on the Dream TE website or in some of the publications that my colleagues and I have put out. And also your local California Math Project sites are involved in a statewide initiative to provide professional development in these areas. So please contact your local sites. You can look them up through the CSMP or cmpso.org website there. Thanks you all for taking the time to attend this session today.